Okay. In this video, I'm going to discuss about chain rule for integration. Chain rule for integration. So, example number 1. What is the integration of quantity of 5w minus 4 raised to 8 dw? So first off, what I'm going to do is to assume this inner function right here as our u. So this our u is equal to 5w minus 4. So we get the du. We find what is the derivatives of this u. So we have du is equal to 5 dw. Solving for dw, we get dw is equal to du over 5. Okay, so since we have assumed that our inner function is equal to u, so our function now becomes u raised to 8 dw. So again, what is our dw? Du over 5. So we just copy it. So 8 raised to u raised to 8 times du over 5. So this becomes 1/5 integration of u raised to 8 du, and this is equal to 1/5 times u raised to 9 over 9, since we just added 1 to the exponent 8 and divided by the sum of the exponent plus 1. So this is our answer, but this is not yet our final answer. So this becomes u raised to 9, 5 times 9 is just 45, plus u. So we have assumed that our u is just equal to 5w minus 4, so this becomes 5w minus 4 raised to 9 over 45 plus c. So this is not our final answer. Okay. So next, what is the integration of square root of quantity of 4y minus 3 dy? So again, we can rewrite this expression right here as 4y, quantity of 4y minus 3 raised to 1/2. This is just the same as this. Okay. Now, what I'm going to do is, since we have already rewrite it, So u is just equal to the inner function, which is 4y minus 3. So du is just equal to 4 dy, and our dy is just equal to du over 4. Integration of u raised to 1/2 times du over 4. Since this is our dy, we have just changed it, and this becomes 1/4 integration of u raised to 1/2 du. Now what I'm going to do is to just add 1 to this exponent. So u 1/2 plus 1 is just equal to 3/2 over 3/2 plus c. This is equal to 1/4 times 2/2, because we multiply this 2 times u raised to 3/2 plus c, and this is equal to 1/6 u raised to 3/2 plus c. It's equal to 1/6 4y minus 3 raised to 3/2 plus c, and this is our final answer. So next, problem number 3. What is the integration of 2z raised to 3 dz over quantity of 1 minus 3z raised to 4 raised to 6? Okay, so our u here is just equal to this. We assume that this is our u. Okay, so u is equal to 1 minus 3z raised to 4. So our du then is just equal to negative 12, which is the derivatives of this function, z raised to 3 dc. So solving for dc, we get du over negative 12 z raised to 3, and this is our dc. Okay, so this becomes integration of 2c raised to 3 dz over u raised to 6. It's just equal to 2z raised to 3 over u raised to 6 times du over negative 12c raised to 3, and this is equal to negative 1/6 integration of du over u raised to 6, and this is just equal to negative 1 6 over u raised to negative 6 bu, and this becomes negative 6 negative 1 6 I mean u raised to negative 5, since we add 1 to the exponent, that becomes negative 5, so over negative 5 plus c. So here this becomes 1 over 30 u raised to negative 5 plus c, which is just equal to 1 over 30 times, what is the value of RU? This one, 1 minus 3z raised to 4 raised to negative 5 plus c, or we can also write this as 1 over 30 times 1 minus 3z raised to 4 raised to 5 plus c. And this is our final answer. So next, problem number 4. Problem number 4. What is the integration of cosine 2x times 1 minus sine 2x dx? So our u is just equal to 1 minus sine 2x. Then solving for du, we get negative 2 cosine 2x dx, or dx is just equal to du over negative 2 cosine 2x. This becomes cosine 2x u raised to 1/2 then dx is equal to cosine 2x u raised to 1/2, since we have radical signs here, which is the square root, so we raise it to 1/2. This becomes cosine 2x times u raised to 1/2 times du over negative 2 cosine 2x. This becomes equals negative 1/2 integration of u raised to 1/2 times du, which is just equal to negative 1/2 times u raised to 3/2, because we have added 1 to the exponent 1/2 over 3/2 plus c. This is equal to negative 1/2 times 2/3 times u raised to 3/2 plus c. So this is equal to 1/3 times 1 minus sine 2x raised to 3/2 plus c, and this is our final answer.